Good evening, everyone. Thank you very much for coming and hopefully enjoying what I'm going to say. One of the first times I introduced a lecture here, rather than gave a lecture, which must have been about 12 years ago, was to the software engineering director of Industrial Light and Magic. Now, some of you will recognize that Industrial Light and Magic was one of the few firms that developed software for computer-generated images, CGI, as it is known. And we had the privilege of seeing an advanced clip of the then #2 Star Wars movie in this room. I say that because at that time, the idea that you could generate bits of mainstream movies using computers seemed to be absolutely science fiction, and yet we generated it here and showed it here. Now, it's part of our infrastructure. We take it for granted that CGI is bedded in almost every movie we see, whether or not we really notice it or not, because it's got really good. The point about that story is 15 years ago, CGI wasn't part of the infrastructure. Now it is. And we sort of forget about it. And that is generally true of infrastructure. Whilst it's all working perfectly, we don't take an awful lot of notice of it. But when it breaks, we do. And that will be part of the thesis, only one part of the thesis of what I want to talk about this evening. All right, that didn't work, but that should. So this is the agenda I'd like to adopt as I go through my lecture tonight. Firstly, to very briefly talk about what the nature of infrastructure is, just to make sure we're all on the same page, because it does mean different things to different people. To talk a little bit about how we're going to develop it sustainably. The fashionable area of sustainability, of course, is environment. But actually, I want to broaden that definition, because sustainability actually is for the human species survival as well as the planet's survival. Then to pick on 4 areas where I think there are issues that are worthy of debate and where they're worthy of government policy and industrial policy and academic research being furthered. And then to be slightly more provocative and talk about how do we take a systems view of all of infrastructure in one go. I'll briefly touch on what the National Infrastructure Plan is in this country and what is being executed right now. Some observations, and then, for some of you will have heard me lecture on various topics in the past, will know that I have a habit of leaving some provocative remarks at the end, hopefully to excite questions and even more vigorous thought. And I hope that's in the tradition of the lecture series that IET Mountbatten created those many years ago. So that's my agenda. So what do we mean by infrastructure? What we mean by infrastructure is those things on the left, which most of the time we never see, as I've indicated earlier, because they work perfectly most of the time. We only know about infrastructure when water suddenly starts welling out of the pavement or out of the middle of the road and doing damage to our roads, and quite often freezing in the middle of the winter, because quite often that's when it happens. And of course, what we really want to avoid in what we like to think of as being a developed society that we live in is descending too rapidly into the situation on the right, which, of course, unfortunately, too many people on this planet live in those conditions. What was interesting about the effect of Sandy on New Jersey were commentaries that came out of New Jersey saying that they had descended to something approaching that, obviously not as bad as that, in a matter of a few days when their infrastructure was overwhelmed by incursion of water and wind and damage. So those are the sorts of topics that I'm going to touch on. To be more detailed, the infrastructure sectors that I have been working on, and indeed I'll tell you a bit about how we've got to where we've got to, are those 4 sectors. As was said in the introduction, I've been the Chief Scientific Advisor in the Department for Transport, and when I arrived there, I very naively looked for an integrated transport strategy. I realised very quickly how naive that was, and discovered not only were the sectors broken up, they were broken up in all sorts of different ways, both nationally, regionally, technically, organisationally, and from a regulatory point of view. And once you get into all those many subdivisions on transport, it's no wonder that our journey experience, which of course is what matters to us as individuals, or our pieces of freight that we like to push around, we must remember we use freight as well as people, is so disaggregated and quite often uncomfortable. I very mischievously said to one of my colleagues in the Department for Transport, it should be called the Department for Journeys, then we might actually deliver what people wanted. Didn't go down very well. However, in examining that situation, I started to understand why we had got into that situation, because clearly, on a more serious point, it wasn't by accident that it was like that. It had actually grown like that through a whole process of evolution from the end of the Second World War, when there was a nationalised Department for Transport that did have an integrated transport strategy. And it had been allowed to disaggregate through various moves of privatisation and agency activity in the 1980s and 1990s. I briefly, before I became the CSA in Biz, also had the energy portfolio. Some of you will remember there was what is called in Whitehall a machinery of government change when various governments were created or merged. And I obviously looked to see what the situation was in energy, and of course discovered how disaggregated the energy situation was as well. That electricity and oil and gas are not in any way treated as a common set of infrastructural components that delivers energy for our use in various ways. I knew a lot about ICT from various backgrounds, and of course that had never, apart from the telecoms bit, the I and the T bit had never been really involved in government. So that was also fairly disaggregated. Water and waste treatment, in other words sewage, was actually in a better place. Solid waste was not. In other words, domestic and industrial waste. And then I got really worried because I started to realise that all these things had to work together in order to deliver the efficacy that we expect to have in a developed society. At the same time, coincidentally, a dinner was held by the Council for Science and Technology, which is the Prime Minister's Advisory Board, at that time co-chaired by Sir John Beddington and Dame Janet Finch. And there were two guests of honour. I was one, and the other was the Permanent Secretary to Number 10. And John had not warned me that he was going to ask me this question that night, and he said, "Brian, what should the CST be studying next?" And I just got to the point of getting extremely worried about this subject as a subject of national significance. So I mischievously said, we ought to be looking at how do we develop better science, better engineering evidence for why we should go about modernising Victorian infrastructure in the UK. And after they got over, isn't that boring, and started to realise, no, it isn't boring, actually it's very important, they committed a study to do exactly that. And that's what happened next, was the Council for Science and Technology did a study on exactly that subject. And along doing that study, we discovered how important infrastructure was. It obviously supports economic activity and growth. All of you who work in any form of business in this country will know that without those things that I've described as part of our infrastructure, you couldn't run a business. You couldn't run the developed business both nationally and internationally that you're involved in. And you certainly couldn't sustain growth. And of course, growth is the mantra of the current government's ambition to move us forward. So it's really rather important that we understand how infrastructure affects growth. And indeed, it is now a major activity within the Treasury. It's also important as an activity for attracting inward investment, both human and financial capital, into the UK. Without it, we are less attractive to people who can move money and people around. The financial markets, of course, have known that for some time, which is why they've maintained, in terms of the infrastructure they need, which is ICT, a very leading position across the planet compared with others. It has been the competitive edge of the City of London for some time. How much lead they've got at the moment, of course, you can have a debate about. But it's not true of other parts of our infrastructure in other parts of the country. We have to respond to a changing world. That is not only climate change, it's changing demographics, it's changing migration strategies, it's population growth, and it's changing expectations. So there's lots of changes that are happening in the context in which our infrastructure exists. And we need to be able to think about how do we adapt our infrastructure to take account of that, which when it was built 150 years ago, some of it, those considerations were not put in place. So we have a relatively rigid, brittle infrastructure that is not designed to adapt and flex according to the changing circumstance. We have a longer living population in this country. We have a bigger ethnic mix. So social inclusion is important because some of the factors involved in infrastructure affect those inclusion properties. And in fact, when you look at it in more detail, particularly in urban areas, it really does determine how we live. There's an old adage that you get what you plan for. And so if you plan for cities full of cars, you get cities full of cars and lots of congestion. If you plan for cities full of pedestrians and walking around and cycling, you get walking around and cycling. So planning, which in this country means authority to proceed, when in fact for most of us, actually what we mean by planning is designing things we want. Most engineers would use the word planning in a different sense from what it's used in Whitehall, does determine how we live in the future. So the whole area of design is now becoming a really crucial area in infrastructure because it does affect the nature of what we end up with, what its purpose is. So the challenges we've got are aging components, and most of us who live in any part of urban Britain will see pictures like the one at the top right of footpaths closed because something's being dug up. As a little aside, I cannot understand why we are not using structured underground engineering in the way we use structured above ground engineering for putting utilities that are below ground. We continue to dig trenches and bury cables in the mud, and then are surprised why it's difficult to dig it up again. We don't do that above ground. We have loads of structures which we use for making sure things are easily maintained, and we somehow don't do it underground. I don't understand why. We have capacity issues. Most of us in London recognise the population walking around on pavements, getting on and off buses. We have climate change to deal with, and it has been said, not only mitigation but also adaptation. And adaptation could hit us, the need for adaptation, sorry, could hit us before the need for mitigation, although we must do both. We have socio-demographic change, and I've probably said enough about that. But we also have extreme events, weather, terrorism, failure and accidents. And I'd just like to mention a couple of weather incidents, one illustrated in the bottom right-hand corner. Most of you will recognise Tewkesbury Abbey. It's been there for centuries. You'll notice it isn't flooded. When they built that, they knew where to put things. Where have we got most of our built assets now? On floodplains, and they get flooded. And indeed, that flood very narrowly missed taking out an electricity substation and a water treatment works, which had it done so, many hundreds of thousands of people would have been without water and electricity, which of course has just happened in New Jersey, because they didn't plan for that, and indeed there is going to be quite a lot of review of what's happened in New Jersey. The other topic I'd just like to touch on, some of you can come and beat me up afterwards, was the incident of the volcanic ash and its disruption to air transport. Now, most of you will think, how did we not see that coming? And yes, the chief scientific advisor sat round a table after the event and said, how did we not see that coming? And we started to analyse the evidence of what we could have looked for to see whether we should have been able to see it coming. And there are 5 factors which coincided that caused that to be particularly disruptive. And even if we'd spotted 4 of them, we wouldn't have spotted the 5th. And those were that volcano, indeed Icelandic volcanoes, hadn't erupted very much for the previous 30 years. There was a statistically unlikely 30 years of quiescent behaviour compared with the last 1,000. The Icelanders have very good records of their volcanic activity. That particular volcano had about 100 metres of ice over its cone. And when it blew, it took that and blew it very high up in the atmosphere. We had almost no knowledge of what blowing a volcano through a large ice cap was going to do, because it hadn't happened in any place where we'd done any decent measurements. So that was the second thing. It was very unusual. Instead of a volcano producing large particles of ash and it dropping very quickly, and hence no big problem, this stuff blew right up into the stratosphere and then spread around for weeks in very fine-grained particles, but we didn't know was going to happen. Third thing was we looked at the meteorology because it affected most of Western Europe. The winds in April predominantly blow from the northwest to the southeast. They don't do it in any other time of the year for weeks at an end, but they do in April statistically, and that happened to be a rather long tail end statistically event. It blew for quite a long time. Easter fell that weekend. Easter can move around by about 6 weeks, but it happened to be that weekend. And most telling of all was in that 30-year period, going back to the beginning, we'd created civil aviation in Europe at a much greater density than we had 30 years before. So we had no idea what it was going to do to civil aviation. You put 5 things together which caused that particular event to be particularly disruptive. When we look back, the fact that we took 5 days to decide what the density and accumulation in an engine of ash could be for them to fly safely, I think was actually amazing that we did it in 5 days, but most people still look back and think, why didn't they just know that automatically? It was a very complex issue, and it took the rest of our community into a space where we started to examine the impact of extreme events on infrastructure and try to understand the effect of those extreme events. Now, I've been at a workshop today with Japanese scientists who've been talking about the effect of the tsunami and the earthquake on Japan. So if you think we've got a problem, they have a really, really difficult problem because the effect they had was absolutely unexpected. And the worst case, I hadn't seen these numbers before today, they've now worked out what the height of the waves were in certain parts of the tsunami that hit Japan, and some places had a 50-metre high wave that came ashore. And they're now worried as to what they could possibly have done in order to mitigate against that, because there's almost no structure you can put in place, and they had almost no warning. So that's a really difficult issue. So extreme events is a real challenge to infrastructure, less of a challenge than it is to us than it is in Japan, but we all have to start worrying about our dependence on extreme events taking out a significant fraction of the infrastructure on which we're dependent. And that brings me to resilience. These major unpredictable external events can cause major disruption if you don't have a really good model across the whole of the infrastructure set of components of how it all works. Some of the changes are creeping changes. They don't happen cataclysmically like a tornado or a volcano or an earthquake. Gradual sea level rise can creep up on you, and then you suddenly find in one extreme event that actually the mean level had gone up. So we are monitoring an awful lot of those sorts of parameters right now, but it costs money to do so, and it's an insurance policy that, of course, we're having to invest in. Some elements of technology evolve. We're discovering concrete structures, for instance, that we built in the 50s and 60s and 70s, and now not as safe as we thought they were going to be. The good news is we over-engineered the Thames barrage. We've actually found we've got 20 years more life in it than we thought we had if we look after it properly, and that's quite important because of the rate at which sea level is rising and how many billions it costs to put something like that in place. And then there's the interaction between external and internal processes. Systems break, components fail. With all the best in the world, sometimes things break. But what the consequences of that breakage will be in a complex set of interdependent components that make up our transport, energy, water, waste, and IT systems is really unpredictable. So we're doing a lot of work in universities, and I'll come back to it in a moment, to see what we can do to even attempt to predict whether or not any failure in any component is likely to have some cascading, multiplicative, combinatorial effect across the whole of our infrastructure. In case you think this is all doom and gloom, I'm an optimist about this. We actually will be able to do quite a lot to make sure that the really bad things don't happen, unless we get a really bad externally applied event, as happened in Japan. So examples of the modernisation that I'm talking about, some of the Londoners will recognise that sign. We've had that all over our pavements for quite a lot. It all disappeared when the Olympics came. It's all going to creep back, I think, now. At the bottom right, we have a marvel of engineering, which is tunnelling underneath us as we sit here, not quite underneath here, I hope, which is the two of the big tunnelling machines that are building Crossrail, which were launched underneath us from Paddington Station. And I came in and out of Paddington on a few days as it happened when that was just disappearing. The thing's half a kilometre long. It's huge. Massive piece of civil engineering that's going on, world-beating engineering. The middle picture, which you probably won't recognise and you don't want to talk about, is the sewage works down in the Thames estuary. Obviously crucial to our public health, and as you're probably aware, we're planning, at least in London, to build a big new sewer right underneath the Thames because it's the only place we can put a tunnel. There's still a big debate about whether it's necessary, whether that's the right solution, but nevertheless, in order to deal with waste, we have to put it somewhere and we have to process it somewhere. And you have to be able to do that if you want to live in a city and deliver the economic and social advantages of a big city like London. You cannot escape that as a possibility. And the boring picture at the top right-hand corner is an example of what most people would think of as, well, that's what the cloud is like. It's obviously a big data center. And there's loads of data centers now growing up all over the place that is managing the data that is coming out of infrastructure and out of our lives. And indeed, anyone who is actually twittering, it's going into something like that. Somewhere. And of course, part of the argument is, where is it? It may not be in this country. Do you care whether it's in this country? So some of the smart solutions, and I'll touch on smart solutions as I go through, demand the fact that you know where your data is and you know that it's accessible. And if the cloud is the way in which ICT back-end provision scale is provided and you do have to know where it is, then there is an issue about resilience of that, the latency that might be important in certain circumstances. So understanding the architecture of the cloud is important, more important for infrastructure than it is for the social use that we are using and even for some business uses. So those are some examples of modernisation. But it also implies integration. And this diagram, which I've adapted from a Department of Transport in the United States, showing how we've got to put the environment, society and the economy together and where what are the issues that lie in the intersections between them. And those two letters in the middle are not an accident. Because this world that we're constructing tends to be me-centric, tends to be aimed at individuals and their rights and their opportunities. And what's interesting to me of my age is actually how we've moved from what I would have written in there, had I been mature enough at the age of 10, community. That actually these things are serving communities, whether they're cities, towns, villages, or virtual communities. They're more aimed now at providing individual services for individual people. And that affects the whole politics and the policies that arise in those various elements. They're all to do with what me as an individual or me as a lobby group, in other words, not just me, but me who are like-minded me, can say to policy practitioners, to financiers, to the media, and cause debate to occur in a way which may not be as objective, it may not be in the public good, as much as it could be. Now, I'm not saying it is, those sorts of debates shouldn't occur. Of course they should occur. That's what a democracy is about. But for everything to be me-centric as the point of integration may be something that is worthy of debate, because the balance between what serves me and what serves communities is why we live in democracies, why we have cities, why we have aggregation of communities. So integration has to be thought about in a much more complex way than just the engineering integration. It's social integration, it's environmental integration, because some environments are damaged if you save other ones, some ecosystems. So the complexity of integration systems, of integrated systems thinking, is something that one needs to worry about. And although that diagram is aimed at, the words are sort of transport biased, you could write a very similar thing for all the other systems that make up infrastructure. And then you have to realize that all of them have to coexist because they're all interacting with each other. And that adds another dimension of complexity. So I said I'd talk about a number of issues under various headings. Environmental issues. The obvious two that I've mentioned already, climate change mitigation, wind farms as one example of how to go about doing it, climate change adaptation. Yes, we don't have to do too much at the barrage yet, but we will have to by about 2050, 2060. So we're going to have to start thinking about what we're going to have to do around that timetable. Pollution is something that sort of got a bit lost in the whole climate change debate, and certainly one of the things I did as the CSA and the DFT was to try and get it back on the agenda, because pollution does affect how we live in an urban environment, particularly how the emission from vehicles, but also the emission from other activities that we like to think of as having to have in a civilized and developed society. There's been obviously a lot of debate just recently about biodiversity and ecosystem services, to use the technical phrase, not only in this country but across the globe. And there's a lot of work that DEFRA and the United Nations indeed has been doing on ecosystem service protection and biodiversity protection. What has also just raised the game is water conservation and food on top of it. Sir John Beddington's Foresight programme in the government has just published a really good report on food and farming, which has gone around the world, has had a huge impact. I've been travelling the world quite a lot just recently. Everyone knows about it, more probably outside this country than in this country. And of course, resource security, whether it's energy security, food security, or anything else. We like to think we can get hold of all the resources we need to live at the quality we live at. Well, infrastructure provides most of those things. It either transports it or it is part of it. The difficulty with these environmental issues, when you list them all and say, yes, I'll have all of that, is how do you get them all to exist simultaneously? How do you get a mature debate about how you balance those things in a national and a local level to deliver all the properties that you want simultaneously. And it's the mature debate is the important thing, because if you have an immature debate, all you hear is lots of noise from different quarters. And I think we're coming out of the noisy phase, because we had a really noisy phase, I think, over the last decade, partly driven by climate change and partly driven by very loud noises about biodiversity. I think everyone is now beginning to realise that they've all got to give up a bit. And if they give up a bit, they'll save a lot more. It's not easy, of course, in what we like to think of as times of austerity. How austere it really is, of course, is a different matter. Of course, it's austere for some. Those are the environmental issues, and they have to couple with this set of issues, the engineering issues, where we have, on a more positive note, innovation opportunities. We have some really inventive people in this country who have developed really smart new materials. The picture on the top right is carbon nanotubes, which are being used in a lot of places, but one of the most interesting that I've found is water purification. You can buy a product, British-made, on Amazon for 150 quid, which contains net carbon nanotubes, and you can put any old dirty water in it, pump it a few times and get drinking water out. Now the stories and where did I discover that? On television in Canada. Because we don't have dirty water, at least we have enough clean water that we don't have to worry about it. But people who are going on trips around the world have to have that sort of product. You can buy it on Amazon. And it's got carbon nanotubes in it. And those are just one example of where that type of material could be used. But we're also looking at very low carbon cement, new types of ballast for various types of construction in systems. I said I'd say something about smart systems. The picture in the middle is a piece of marketing for a summit meeting in Canberra that was set up by the Smart Infrastructure Research Facility at a university just south of Sydney. And I had the privilege of opening that for them in Canberra, in the Parliament building, because the Australian government and all the state governments realised that infrastructure is very important to Australia. So they've put 100 million Australian dollars into this research facility in one university in order to do research in how to develop and maintain smart infrastructure. Now, smart is actually not smart in the ICT sense of the word. It systems, can't remember what it stands for, but it isn't. It's all of those things. Research and teaching, I know, are the last two. Analysis, modelling. There we go. And what they're about is incorporating smart thinking into everything else they do. Because smart can become really dumb if you don't make sure you understand the quality of the data, the provenance of the data, the way it gets used, how dependent you become on it, and so on. So the information architecture, the information management processes that have to exist to make smart work, whether it's smart metering, smart transport, smart water management, it all has to work in a way which is consistent with the purpose of putting smart in the first place. And those systems, of course, have to be able to change. One of the advantages of smart systems is that it's likely to make us more able to make our systems adaptable, as long as the physical pieces, the civil engineering, the mechanical engineering is adaptable too. And another innovative opportunity which I've seen in Singapore is the use of prefabrication, that you don't build buildings, you don't build infrastructure on site, you make a lot of it off-site where you can do high precision component manufacture and then assemble it on site. It's much cheaper, quicker, has lower environmental impact. In order to do that, you need multidisciplinary skills. And our educational system at the moment in the UK is not necessarily set up brilliantly to deliver those multidisciplinary skills. We tend still to have reward structures and educational structures which don't help the multidisciplinary activity that is needed in order to deal with this broad range of engineering that is coming at us. This should be happening at scale, of course. And the scale at which we are thinking at the moment is relatively small. We now have computing models, we have analysis models, we have data sets that allows us to do things at a much larger scale than we historically have. But we're not really addressing that in the commercial area. We are in the academic area. We're a bit poor on data at the moment because people seem to think data ownership is good for them. Actually, data sharing is much better for them. And that means the modelling and the exploitation of data from embedded sensors could actually transform the way in which we think about engineering. we could put data-driven engineering right the way through the life cycle of infrastructure, as happens in certain industries, the most important of which is aviation. Aviation has, and civil aviation in particular, has data embedded right the way through it. And most of you who fly will know that every aero engine, every jet engine on every aircraft is being continually monitored second by second for all the parameters that might matter with regard to its safety and its functionality, which of course as a flyer you're very keen about, and since I'm flying to Auckland, New Zealand tomorrow night, I'm really keen that that happens. So there's a whole issue of how we transform our engineering philosophy in thinking about what infrastructure is and how we incorporate new innovative approaches in all the branches of engineering in an integrated way to deliver better solutions. I said I'd touch on economic solutions as well, economic issues. Our economics has been driven very much by traditional single factor evaluation, and indeed that has not really helped give an understanding of the multiple factors that matter and how we do risk-benefit management in this complex area. I deliberately put up a picture of two very eminent economists. In fact, they won the Nobel Prize, Professors Roth and Shapley this year, because they started the process of looking at game theoretic economics. And when you think about how the negotiations and the evaluations work in this type of area, you find that actually some of the foundations of their economics is relevant to what we're doing. To bring it down to a little bit more prosaic area, putting a value on resilience is really important. Most of you have insurance policies for something in your houses or cars. It's regulated, of course, for your cars because you might damage someone else. But you don't have to have insurance for property unless the mortgage broker says you should. So when you say, have we invested in resilience, have we put enough extra engineering or provision in the way it's operated in infrastructural components, unless there's a safety issue, which in nuclear and in aviation and in one or two other areas, rail in particular there is, you find that actually, well, if the market has chosen how to do it and it isn't regulated, that there is more resilience. There isn't. And so when things fail, and this is exactly what's happened in New Jersey, you find actually people are in a very difficult position because they don't have enough provision either to prevent things happening or to recover from things happening. So putting a price and a value on resilience is a major economic challenge, and indeed we're doing at my university, but also in other universities, work with the Treasury on trying to understand how to do that. In fact, we're not only doing it with the Treasury, we'll be pleased to know we're doing it with the European Investment Bank, because there's something to do with the resilience of Europe in the whole of this as well. Full life cycle economics, we tend to break it up into compartments and not let the compartments talk to each other. So we do the buying bit, then we do the operating bit, and then we do the decommissioning bit as if they're all separable. Well, they're not, because of the asset value or leakage that's accumulated during the life of the asset. And that means we need long-term thinking and policy stability. Now those, you might say that's dream world. We're not going to go anywhere near that. And I'll come back to where we've moved some of our government thinking already into a place which is better than it was 3 years ago. It's still not good enough, but it's moving in the right direction. But it also means we need business models for public-private partnerships, not just for the procurement bit, for the whole portfolio of portfolios, programs, projects, and importantly, options, because this stuff lasts a long time. So how do you buy options in future infrastructure when you're investing now? One of the things we're studying, and I'm not going to put a name on the particular project, but you can imagine a project where you might want to build a very long piece of transport real estate between two big cities. What else could you put in the ground while you do it? You could put loads of empty tubes through which you could put fibre optics or water or some other vehicle that you could propagate down the tube. It's very difficult to get government to even think that's a good idea at the moment, although we're moving that direction, because the cost of doing it now is trivial. The cost of doing it in 20 years' time when you might need it would be huge if you haven't put in the basic provision for putting something else down a long, thin tube. And that's buying an option. So that's just a simple example of buying a future option. Some infrastructural areas are very good at buying options, the oil industry in particular. They know how to buy options on resources. But we could do that more innovatively in other markets, I'm sure. And then, and most importantly, in my view, of the whole lot of issues that I've just touched on, is governance. We have disaggregated regulation. We have, the last count, about 37 regulators that play in the infrastructure space around this country. And they don't have any obligation to talk to each other and no obligation to make sure their regulations are coherent. So no wonder we're in a position where everything sort of tends to clash with each other periodically. We have privatised. We've privatised in different ways in different sectors, and then we expect it all to work together. The picture is a deliberately constructed, chosen picture from the many, many pictures you could choose of aerial shots of London. Because it's one of the very few that I could find where you could see the Mayor of London's office on the south bank of the Thames. Those of you who know London could probably find the Mansion House for the City of London. And in the distance, you can see two bright spikes just to the left of the Shard, which are what is now Queen Elizabeth Tower and the rest of the Palace of Westminster. So we have three scales of government. We have the old City of London, we have Greater London, and we have the nation government sitting very close together. And the tensions in the political frameworks of what is important with regard to infrastructure, which we all know about, both certainly in the southeast, but we know about nationally, particularly around aviation, is a major tension. So where is the power base going to be? We know where it is now because the money is allocated into the Treasury, so it's all down in the distance there. But already we're seeing city mayors, not just in this country, but in other countries, saying, I do the tax take. Why don't I keep more of the money to spend in my own city to deliver more value to my citizens who live in my city? 70% of the people will be living in 70 cities in 20 years' time around the planet. So city politics and city power is going to become very important with regard to infrastructure. And the money will not, at the moment, follow that power. And that's going to be a very interesting battle to observe. I probably don't need to say very much about short-term thinking. I do need to say something about short-term doing, because we have a lot of short-term thinking, and that really does cause what happens to be relatively short-term things, 3 to 5 years within an electoral cycle. We're not the only country that suffers from that. Everywhere I go and talk about this issue, everyone in a democracy says exactly the same thing. The only country that looks at us rather mysteriously is Singapore, who don't understand that because they've had a 40-year headline of what they're going to do. And they have had a 40-year headline ever since the early 70s. Now, you could argue their politics would be unacceptable to us. Their quality of life probably has some features which we would find unacceptable, but there's lots of other things that we all quite like about Singapore. And that's quite interesting, I think, is what could we learn from them. That's why I'm stopping for a day on the way back from Australia and New Zealand to talk to their Centre for Livable Cities, which they've set up in one of their universities, because we have a program in the UCL as well on livable cities. And we're starting a dialogue to see what we can learn from each other, because they are suddenly realising that their population won't tolerate for very much longer being told how to live by their government. They're interested in social research, social sciences, which they haven't really been interested in before. It's all been engineering and technology. And we're suddenly becoming really interested in engineering and rigour and governance because, well, they've had an extreme version. So there's some quite interesting dialogues going on. Indecision is one of the worst things we're suffering from at the moment, in my view, in terms of governance. All sorts of reasons why it's much easier to put off making a decision about something than to make a decision to do something. And how we get out of that logjam, I don't have very many solutions for at the moment. We have polarised factions over issues, and we have a lack of expertise in the governance class. And that is a major failing. And obviously, as an advisor to, now ex-advisor to government, that was something I was there to try and supplement as best I could. So what is this systems view of infrastructure that I've been sort of hinting is a good idea? There's Terminal 5, just before it was finished, integrating the aviation, the movement of people by a number of modes in and out of the terminal and the road system that sat around it, the M25, M4. It's a really good example of how systems were thought about in an integrated way, as much as possible within the constraints that Terminal 5 was put under. Top right-hand corner is the King's Cross development, just behind King's Cross. That's, again, an artist's impression of the architecture applied to it. But again, it's an example of where all the infrastructural components I've touched on were put in as part of the design in an integrated way. There is on the Treasury website a reference to a report that uses this as a case study that shows what the value add was of doing that. It's measured in billions in a £10 billion programme. It's very significant saving if you think about all those factors in an integrated way. But it happened there because a single voice of authority managed to own and govern the whole thing, much as the same way Sir John Armitt did for the Olympics. Once you've got total control in one mind, or a few sets of minds, it's a lot easier. It looks a bit totalitarian, but it can happen even in our country. The left-hand side is the latest ecosystem suburb in Singapore, which I had the privilege of being taken around the last time I was there. And they have paid a lot of attention to livability, how people wanted to live. They've consulted the people who live there and talked to them and listened to them about what it was they wanted within their newly developed ecosystem, very low carbon environment. And then they built it, and very fast. And on the right is a view that was taken by the Environment Agency on behalf of DEFRA of where some of these infrastructural components might work together. Again, that's come out of one of the reports that was referenced earlier, and although I know you won't be able to read the detail, it gives you an indication of the sorts of parameters that you have to worry about. So we've got this innovation in systems thinking to be concerned with. Integration of infrastructure and construction design. And the innovation will occur at the interface, and it balances all these various factors. Now, architects and designers are beginning to start to do this at the top end of the market, but most of the work they're doing is outside this country. We have the expertise to know how to do this, but we're doing it in the Middle East and the Far East because our community isn't asking the right questions of our infrastructure developers yet, except in some extreme circumstances. I've just given you a couple. We're trying to understand all those human and environmental impact factors at the same time, and importantly, embed data collection so that we've got information integration across the whole of the life cycle, across a range of timescales. So a number of universities are working in the space of innovating in systems thinking, and they're working very closely with large engineering companies in a range of engineering disciplines to put all this into practice very quickly. I'm now going to become slightly more upbeat, because actually what we're doing, the engineers are getting together with the academics to start producing decent and better engineering solutions. What we need is clients who want to buy these things from those communities that know how to provide them. The important documents in this space, I mentioned the Council for Science and Technology report, that is there. And that resulted in a National Infrastructure Plan, which is owned and run by the Treasury. After Christmas, there will be a Minister for Infrastructure. Those of you who will remember an edition of Yes Minister about 40 years ago, when to be a Minister for Infrastructure was about the lowest of the low. Clearly, that is not the case at the moment. And on the right is a brochure, which I've left, will be a few copies, I only had a few outside, which is the research manifesto that the Engineering and Physical Sciences Research Council has produced on what research they are funding and what ought to be funded. All of these documents are online, and I'm sure I could help you, but I'm sure others could help you find them if you have difficulty finding them. And that will give you much more background. Each of them has loads of documents underneath them which you can tree into. So the NIP, which is the important part of the government's activity, survived the election. It was based on that report, but it is building a plan from a pipeline of projects that pre-existed. In other words, it's not a top-down strategic view of what the country needs, it's an assemblage of what the country thought it needed to have at relatively local and fine-grained level. We're doing some studies on interdependencies, resilience evaluation, whole life cycle costing and procurement methods. There's an integrated set of activities on one or two, actually 4 examples, and a number of us are working with the Treasury on that. In particular, we're extending the ways in which data gets collected and exploited from what happens in the buildings environment, building information modelling, for those who know about BIM. We're extending BIM and looking at where it fails and inventing new ideas there. New business models, better regulatory coherence. These things I've all touched on already. Developing an engineering roadmap, which is the Deputy President mentioned as one of the activities that will be published next year, and the IET and Institute of Civil Engineers very heavily involved in that with Infrastructure UK. Importantly, skills. We need the polymath skills at a range of different levels so that people understand that although they may be expert in one area, other people's voices in other engineering disciplines have weight and are important. And the research programs, which I've mentioned already. So I said I'd close with, first of all, some observations and then some provocation. Much to our delight, those of us who are involved in that Council for Science and Technology report, almost all the recommendations are completed or in progress. And that's almost a first for a major advisory group in the government. Academia, government and industry are fully engaged and they're pretty well together. We're pretty well on the same page about most of these things. There's still work to do, a lot of work to do. What I am very pleased to say is that in travelling the world and talking about this subject outside this country, a lot of what I've discussed this evening, other countries are now realising is something they've not to think about. We are ahead of the world, which is surprising, but nice. Not on everything. I think skills development could be the limiting factor. How fast we can do this stuff may be limited by how many skilled people we've got in the whole range of skills we need. But it therefore needs to be thought about in the analysis. We can't just charge ahead and say, here's a target, let's do this, because actually we may not have enough people, enough skilled people. Politics does get in the way. Either it's a spending review, budget, or an election. Maintaining the continuity of these activities through all of these political discontinuities is crucial, because this is a long-term business, and we have a history of not being able to own long-term things, long-term policies, long-term strategies. We've got to do something about that. So those are my observations. And then just to finish, some provocation. I mentioned that the NIP was very much a bottom-up assembly of short-term needs. What would it take for us to develop a long-term strategic view of the purpose of our infrastructure? What sort of country would we want? Why is that not part of a political manifesto? It's never been part of a political manifesto, and I don't see why that should not be the case. That may be me being a naive politician. But nevertheless, you could argue that those who understand this business, which is the engineering community plus a few others, could put their heads together and start producing some, at least white papers, which provoked our politicians into thinking this was an area that was worthy of consideration as a more mainstream political issue than it would appear to have been in the past. Engineers actually are filling quite a number of the leadership positions. Sir John Armitt's just been asked to do a very big job for the Shadow Chancellor. Crossrail is being chaired by an engineer. A number of our big activities are being looked after by engineers, but we need more, and we need more leadership in other disciplines because of the multifactorial nature of this. How's that going to happen? I don't see it happening by accident. It's going to happen because this sort of agenda is visible and the holes in delivering the strategy and the policies are visible to everyone because it is a public debate. There isn't a public debate about this subject yet, and that's why I was really delighted to be given the opportunity to at least raise the possibility that that should be something that could be prompted from this institution and from others. We seem to have a difficulty in this country in understanding why we need national strategic planning. The Realpolitik, a German phrase, is not synonymous with le grand projet, a French phrase, which I found intriguing when I wrote this. We actually don't have language which describes those two things, but the French and the Germans do. But actually, we ought to be able to develop a strategic plan for a long-term future which is compatible with our Realpolitik without then having to do le grand projet in the way that the French have a culture of being able to do. But that means we need, the other metaphor I use is we ought to be able to, as it were, describe the picture on the lid of the jigsaw and then set off teams of people to do bits of the jigsaw, but in harmony with each other. And I don't see why we can't do that, but we do seem to have a mental block on understanding how to go about doing that. And then finally, and this is a more immediate thing, in the last couple of weeks, Danny Alexander, Secretary in the Treasury, chairs a body called the National Infrastructure Plan Strategic Engagement Forum. Mouthful, NIPSEF. But it's not big enough. It doesn't encapsulate all the stakeholders in what is really about what is important about infrastructure. It's mainly about government departments and the construction industry. Those aren't the only important players in this space. So a challenge to anyone in the room who has any influence over such matters is to extend the remit of NIPSEF to include academia, to include other bodies who have other interests from those long lists of sets of issues that I described earlier. Because if we did that in a big National Infrastructure Council, we might stand some chance of that surviving through elections, through electoral cycles, through budgeting processes. And then we've got a means by which we can maintain, without inventing a thing called a Royal Commission, which is how we used to do it, a body which owns the long-term strategic view of how we take forward the maintenance of infrastructure which will maintain us as a developed society. Thank you very much.